What if the ground beneath your feet suddenly started moving? Imagine buildings shaking, roads cracking, and mountains rising before your eyes. Earthquakes, volcanoes, and giant mountain ranges all have one thing in common. They are caused by a powerful process called plate tectonics. The Earth is made up of several layers, each with different properties and temperatures. Starting from the outside, we have the crust, which is the thin, rocky layer where we live. Beneath it lies the mantle, a thick layer of hot rock. Deeper still are the outer core and inner core, which are mostly made of iron and nickel. Understanding these layers helps us understand how tectonic plates move and shape our planet. The outer, rigid layer of the Earth is called the lithosphere. It includes the crust and the uppermost part of the mantle. However, beneath it lies a softer and hotter layer called the asthenosphere. Because this layer can slowly flow, the tectonic plates above it are able to move. This movement is responsible for many geological events, including earthquakes, volcanoes, and mountain building. Scientists have identified several major tectonic plates that cover the Earth's surface. Some of the largest include the Pacific Plate, African Plate, Eurasian Plate, North American Plate, South American Plate, Arabian Plate, Indo-Australian Plate, and Antarctic Plate. These plates move only a few centimeters each year, which is about as fast as your fingernails grow. Although the movement is slow, over millions of years, it can completely reshape continents and oceans. Around 200 million years ago, all of Earth's continents were joined together in a giant supercontinent known as Pangaea. Over time, tectonic plates slowly moved apart, causing the continents to drift away from one another. This process is known as continental drift. Even today, the continents are still moving, although the movement is too slow for us to notice in our daily lives. The areas where tectonic plates meet are called plate boundaries. These regions are among the most active places on Earth. Most earthquakes and volcanoes occur near these boundaries. The formation of mountains and even the creation of new ocean floors are also directly linked to the movement of tectonic plates. Scientists classify plate boundaries into three main types based on how the plates move. Convergent boundaries occur when plates move toward each other. Divergent boundaries form when plates move apart. Transform boundaries develop when plates slide past one another. Let's explore each type in more detail. A convergent boundary forms when two tectonic plates move toward each other. When this happens, enormous pressure builds up between the plates. Sometimes, one plate is forced beneath the other in a process called subduction. In other cases, two continental plates collide and push the land upward. These collisions can create mountains, volcanoes, and deep ocean trenches. About 50 million years ago, the Indian Plate started moving northward across the ancient Tethys Ocean. It was once part of a huge southern supercontinent called Gondwana. Over millions of years, powerful forces inside the Earth slowly pushed the plate toward the Eurasian Plate, a journey that would eventually lead to the formation of the Himalayas. As the Indian plate moved north, it collided with the Eurasian plate. The crust crumpled, folded, and pushed upward over millions of years. This powerful collision formed the Himalayas, the tallest mountain range on Earth. Even today, the Indian plate is still moving north slowly, which is why earthquakes still occur in this region. A divergent boundary occurs when two tectonic plates move away from each other. As the plates separate, magma from deep within the mantle rises toward the surface. When this magma cools, it forms new crust. This process continuously creates new sections of Earth's surface and plays an important role in the growth of ocean floors. Most divergent boundaries are located beneath the oceans. Here, magma rises through cracks in the ocean floor and creates underwater mountain chains known as mid-ocean ridges. As new crust forms, older crust is pushed away on both sides. This process is called seafloor spreading and is one of the strongest pieces of evidence supporting plate tectonic theory. Transform boundaries form when two tectonic plates slide horizontally past each other. The movement is usually not smooth because friction causes the plates to become locked together. Over time, stress builds up along the boundary. When the stress becomes too great, the plates suddenly slip, releasing energy in the form of an earthquake. A famous example of this type of boundary is California's San Andreas Fault. Plate tectonics is one of the most important theories in Earth science because it explains many of the processes that shape our planet. It helps us understand earthquakes, volcanoes, mountain formation, ocean floor expansion, and continental movement. Without plate tectonics, Earth would be a very different place. The movement of tectonic plates continues to reshape our world every single day. Now you know the incredible story of Earth's moving plates and fault lines. If you enjoyed this lesson, like, share, and subscribe for more exciting geography and science videos.